So we're just going to go over a brief, like I said, overview of the SMS. This is version 13.3. We're also going to be going over some of the coastal modeling system pieces and parts and some user resources that you guys can access to get more information. So the SMS is, we try to have it where the user can do pretty much all of their project within the SMS. There are some pieces that we still like to take outside, and so we have some export tools to be able to export those in either shape files or different types of files so you can pull them into other tools later on. But we typically use this as both a pre-processor and a post-processor, as well as running the models sometimes. So the interface looks something similar to this. This may be a little older image, but I think it's got all the pieces that we currently use. And so there's different parts to it. There's the menu bars, which you'll notice that a lot of the menus for the model specific stuff are gone. And we're doing it a little bit differently and operating within the data tree over here on the side. For some of that, we've got the larger graphics window where you can actually visualize your grids, your bathymetry information, all the different pieces that you load in that's visible in this data tree over here on the left. When you add in solutions, you'll have a time stepping window so you can actually step through each individual time for your output and then be able to see what's going on through that time. There's a help window, status window. I'm not going to go into a lot of detail here. I will cover a few of these toolbars and some of the pieces that we use for the most part. And so with CMS, we use Cartesian grid tools, and there's also a newer U-grid type of tools, but pretty much they're the same thing. CMS is all based on squares and rectangles, and so we're selecting cells. We are creating a grid frame. We can look at different contour labels. Some of the other things that we might decide to work with is some scatter data, and I'll be showing that later today. And so you bring that data in, you can select or create a point. If you notice, some of the tools look very similar. So the ones with an arrow on them are actually selection tools, and the ones without are creation tools, just so you don't get confused there. We can work with the individual elements for the scattered data, which come in as a triangulated network. So they're triangles. And then there are other tools here that come up with working with the map data. So we can select arcs, we can select vertices, nodes, work with a polygon. We can actually build a 2D grid frame. We'll be showing all of these tools later today and throughout the week. So as you pull in different pieces of information into the interface, as I mentioned, there's a data tree that's on the left-hand side, and it holds all the different data. And so at some point, you may have a lot of information here that you might want to look at, but it gets pretty busy. And so we have these collapsible boxes. And so you can actually shrink these things down and then have only the ones open that you want to look at for that particular time. So a little bit of a way to clean that up. But we identify, different things over here. You'll notice in the U-grid data, which is what the CMS flow grid actually comes in as now. We have cell Z. We also have a point Z. We will not be using the point Z, but basically that is the interpolated values at the corners of the cells instead of the cell centers. But CMS only uses the cell centers, and so that's what we will primarily be looking at. You see here we have a few other data sets that are loaded for different pieces of information that is needed in SMS for CMS. So we've got a Manning's N, which is bottom friction. We've got a hard bottom for sediment mobility. We've got a D50, which is the average grain sizes of what's being carried around in the suspended part of the column. And we had an extra hard bottom for whatever reason. This is showing the loaded solutions from an actual grid. So for that simulation, we have a depth and a morphology change that was loaded. We also have the wave grid, scatter data, and other things as well. So a lot of these things, if you go around and play with them or want to be using them, if you right-click on any one of these, you may encounter various different available options. So just as you're working with it, get used to what options are available for each different type of data set that's loaded. So as I mentioned, we like using SMS from the start to the finish for the most part. And so in the beginning, we may be importing all of our background data, which consists of images, scatter points that contain bathymetry or survey data, coastline files, different types of information. Then we pull it in and then we actually build our domain for the CMS grid. And we're able to visualize how all of this looks, define areas where we want additional resolution, whether it be with refined points for the wave grid or with zones, polygons for the flow grid. And then we can run and visualize the results within the SMS as well. So a couple of different things as you're pulling in data. If you have columnar data, XYZ formats, then they will come in through this import wizard, and you'll be able to see and assign which column is which. So in a few cases, we may have several other columns here, and you just need to basically tell the SMS which of those columns provides your eastings, your northings, and then what the actual scalar data associated with that point, whether it be the Z, which is the actual depth that we'll be using for our grids, or it might be a D50 or some other piece of information that you've gotten from someone that you want to assign to those same points as well. So as I mentioned, we pull those scatter points in, they get triangulated into a 10, and then you're able to visualize those. And this little example here, you see that we've got areas where there are no points over a barrier island, and there's connected triangles between the points. So we might want to get rid of those. I'll go into examples of this later on, but you'll want to clean some of these things up for working in CMS. You can visualize that data either, in a plan view. You can actually rotate and look at it obliquely, emphasizing the height or the change in the elevations or depths. And so there's a lot of different ways of visualizing things. We're not going to get into each of that for this week since it's so compressed. But if you have any questions, there's plenty of tools and tutorials on the Aquaveo website, as well as you can contact someone here and we can do some assist for that. You can pull in different types of LiDAR surveys, clouds of data, and be able to work with those. Once you pull that in, we can assign break lines so that we make sure that you get flow that's consistent and that's not broken up by ridges, kind of which is shown here as an example. And then there's different things that we can do once that data is in. We may have multiple data sets that we want to work with, and we'll be going over this particular part later today. But all of this can be manipulated, they can be merged together, and then you can end up with one big data set that's going to provide the bathymetry or some other component for the CMS runs that we're setting up. You can load in topo maps and aerial photos. just to give you a good sense of where you're at and make sure that your points that you're pulling in from your surveys are lining up. And if they don't, then you can change the projections and figure out how things are supposed to line up. But these are other tools that we can utilize to kind of showcase our results a little bit and keep moving. So some pull down menus within the SMS that we'll be using. Under data, there's a few tools. We'll really only be using, for the most part, the dataset toolbox. I'll go into a couple of those. We have film loops that once you have a solution, you can go through several different frames and capture that so you can show it to a customer or look at it later on. You can work with the data in a lot of different ways. You can find specific cells. You can change your display options, which some of the ones that I'll be showing may be different than is the default. And so you would change these display options to make things look similar or to have it in a way that looks right to you and you're comfortable with. Once you get the models inside and created and everything's set up, you'll have to figure out how to tell CMS how to assign the model control, which is all the different parameters and times. And so I'm not going to this into a lot of detail right now because we'll be covering it later in the week. But there's basically in the model control, there's a tab for different processes, and you'll have a chance to enter that information. Similarly, for the wave model, once you load it, there's a new model control. It looks a little bit different, but it's got all the same information on one of these 4 tabs. And we'll be showing how to go through each one of these and set those values for the actual CMS Wave model runs that we'll be doing. Working with CMS Wave, we actually have to pull in spectral energy, which is on a frequency and direction type of grid instead of an XY spatial grid. But all that information is pulled in. You can visualize what it looks like on a polar plane here, and then make sure that it looks right before we actually start running. If you don't have an actual spectral energy file from some gauge or some other method of creating those, you can actually come in and generate your own spectra from wave characteristics, and we'll be showing this a little bit later in the week. But basically, you just have to tell us what the offset is as far as from the start of the run, what the wave angle, wave height, period, and then some spectral defaults, which you can gather and pull in as well. The dataset toolbox I mentioned, there are a lot of different options here that you can go through. And actually, I think the new dataset toolbox actually has quite a few more in there since this image was taken. One of the main things that we will be working with is the data calculator, and that gives us a chance to take the loaded data, perform some calculations, and then create new data sets based on those calculations so that we can use those in a later time. So this kind of shows that a little bit. Got the data calculator, you have everything brought in for what it was actively selected in your data tree. So in this case, we have a grid. We have the capability to access the data from these 4 data sets as well as the solutions through time. We'll be showing this on the final day when we're getting into some post-processing, being able to work with that a little bit. There's also coordinate projections where you come into SMS, you have to tell it, basically this is the area that I'm going to be working, so that when you pull in other data from surveys or different areas, everything kind of lines up and you know exactly where it fits in the area that you're going to be working with. So you'll need to assign projections to every object that comes in, as well as an overall display, which is what the CMS flow or wave grid will actually be running with once the files are exported. And then in post-processing, we can do annotations, graphic images, some animations, like I mentioned earlier, and even very basic plotting capabilities. Some of these tools are being improved upon and changed a little bit, but you're able to do some amount of post-processing within the SMS interface. And then if more is needed, then you can always export those files and then work outside of SMS if needed. And this kind of just shows a few things with the annotation layers where you can add in logos or scale bars, north arrows that actually move with the grid if you look at it in an oblique angle. You can look at your results with contour plots as well as vectors for all the velocity or transport directions, things like that, that you might want to look at, and then overlay that onto some map over an area that is not covered up. So there's a lot of different options you can do for working with your results. So this next slide just basically says how do the different groups obtain and activate SMS. If you're a core user, then we have a help desk here at ERDIC, and you can contact them with the SMS at at USACE Army Mill, and tell them, hey, I need to get a username and activation for SMS 13.3 or whichever version that you want. Tell them how many you need, and we will get you a license for SMS. For everyone else, you need to go through the Aquaveo website. And so this link, I think, is still active and valid. You would go through Aquaveo and request a password. In the first, when it first comes up, you can get an evaluation type license. That's good for about 30 days, I think it is, from your activation, and then test out what you need. And after that, you can contact Aquaveo and look into purchasing the different pieces. I will say that CMS and some other models here at ERDIC are being added to the SMS in a free version of SMS, which is called the community version. So over the next year, all of CMS will be available in that community version. There are a few limitations on that community version, but it should not interfere with using it. So in that way, you'll be able to get Aquaveo and work with CMS or any of the main USACE models without having to pay for the interface. That's a process that we're going through and providing that for everyone. So like I said, I think right now SMS 13.3 has CMS Flow in the community version. CMS Wave is being added right now. Other models are being added as well. So if you have any questions about that, just let us know after this or by email, and we'll try to explain a little bit better. So quickly going through this mission statement, basically CMS was developed to quickly get something together for engineers on their desktops and not have to involve a long process or going through the high performance computing system. And so we've been geared over the last however many years towards smaller projects that fit in the Windows desktop environment. But our grids and domains that we're working with are actually growing and getting larger and larger, and our capabilities are improving, being able to handle larger grids and domains. Coastal modeling system, this kind of gives an overview of the different pieces. There's two main functions with CMS. There's a wave model and there is a flow model. For the wave model, it calculates wave diffraction, reflection, run-up, setup, overtopping. a lot of different processes. And as it's running, it feeds that information to our flow model. It shows that we're passing in the wave height, period, direction, dissipation, and radiation stresses that feed into the hydrodynamics. And so that then goes into another cycle here where we calculate the hydrodynamics, the effect of the sediment transport that's being mobilized, updating the grid eventually, the bed, and dealing with that. And then as a byproduct, we're able to also look at salinities and temperature, even though they don't actually fit in and affect any of the hydrodynamic sediment transporter morphology. They're basically just for the users to be able to see. Hydro does feed into the movement of the salinity and working with the temperatures, but like I said, it doesn't feed back into the rest of it. So this page kind of shows when CMS is the right tool to be used. We have a time scale and a spatial scale, and we're fitting in. This oval is getting a little bit larger over the last 5 to 10 years. We were relatively small at first, but now we're getting into longer and longer simulations over larger and larger spatial scales. And this just kind of explains where some of the other ERDIC models kind of fit into that same scheme as well. There's a table over here that kind of gives a little bit of information about what's available with CMS. But if you have any questions, then you can contact someone here. We also have a user guide that I'm going to talk about a little bit later. That's been updated recently and should have some more information for you guys. Excuse me. So just quickly going into some of the key features for CMS Flow. We've got, it uses the finite volume calculation method, which conserves mass and is relatively stable. We have 3 different ways of dealing with sediment transport and morphology change. Excuse me, I'm getting over a sinus problem here. But we also interact with the wave model, and so we have wave current interactions. All of these different things interact. We are able to nest. I'll show that in a little bit. We have different methods of forcing at the boundaries and over the entire grid with winds and waves. The different grids that we're able to use with CMS Flow. We can still work with non-uniform Cartesian grids, although that is starting to be less and less used. We're now mainly using our telescoping grid, which was developed. It's a quad tree type grid where we can increase resolution very specifically in areas without affecting smaller and smaller cells in the deep water, which was a problem with these Cartesian grids. Our flow model is able to handle these type grids, but the wave model will continue to be on Cartesian grids and have not been updated to the telescoping grid capability yet. So for solver options, we're able to calculate CMS Flow using implicit solution scheme or an explicit solution scheme. Typically, users are using the implicit, which is good for normal tidal flow, long-term morphology. You can have larger time steps, as it shows here, 10 minutes or longer. You want to be careful how long you make these time steps because you may start missing out on different processes that are going on. If you have the need, certain situations, you can switch it to work with the explicit solver. It has a much reduced time step. So you're working on the order of 1 second and less for the most part. But those are good for extensive tidal flats where you have large areas that are wetting and drying, breaching and some supercritical flow. You will probably need to use the explicit solution scheme to handle those. We do have some amount of parallelization built into CMS so that we can utilize extra processors for the computers that are available today. Right now, there is no MPI parallel processing, which is basically allows it to be run on high performance computers with very large domains where it breaks the grid up into multiple pieces. We don't have that yet. We are looking into ways of improving our parallelization schemes so that we can run larger and larger grids a little bit faster and still get good answers. So bear with us as we grow a little bit here. So the parallel processing, it kind of shows a little example of how it does. Basically, how we've got it set up is all the loops within SMS as you're going over all the different cells for the different times. We're able to break those up among different processors and get the answers. And then it brings all that data back together until it needs to break them out again. You don't really necessarily need to know that, but we can use up to 4 threads or 4 processors with the implicit scheme, as this shows. Normally, any more than that, you don't really get much of a speed up. When you're running with the explicit model, however, we can see a little bit of a speed up all the way up to 16 is when we stopped. This was put together before we had machines with more than that. But you do get more of a allowance for speed up over larger number of processors when using the explicit solution scheme. And really helps since you're running with 1 second or less time steps. Some of the hydrodynamics, I'm not going to get into all the equations, but just know that we do have capabilities for lots of different processes that are going on. We handle Coriolis, bottom stresses, wind, different types of stresses here, water surface elevation, velocity, eddy viscosity. We include a lot of terms here in the calculations. Different types of forcing. We have spatially constant and variable wind fields. We can handle wind fields that have atmospheric pressure gradients. We can also turn on wave and roller stressors and get some of the asymmetry due to waves in a limited way because we are a 2D depth average grid. So we also have boundary conditions, different types here. We have closed, which just means where we have land on the other side, there's no flow into that. We have river flow, water level time series that you can apply in the offshore or behind a barrier island, as long as you have data for it. We have nesting, I'll show that in a minute. Tidal database, we can actually extract from tidal databases so that each cell along your grid on the CMS flow grid will have different values. This is really important for larger grids because the phasing will change once you get from one side of the grid to the other. And so it's nice to have that handled where every cell has its own values. Otherwise, if you have a relatively small grid, you can assign one value for the entire offshore edge, and then you're good to go. Just quickly showing the nested grid. This could be a CMS grid, it could be an ADSER grid. We're working on connections to other grids as well, other types of models as well. But essentially, you have a larger grid and a smaller child grid, and you may force the larger grid with whatever you have. And then once you are ready to run your smaller grid, you extract the water surface elevations and velocities from that parent grid, and then you're able to reproduce that on the smaller domain. This is really handy in areas where you really have a large grid, a large domain, and you're not able to add in enough cells to get answers that quickly. So you can have coarser cells to get the main answer and then force that onto a smaller, more resolved grid. And we're using this capability more and more. So just showing some of the results from forcing the child grid from the parent, pretty decent with water surface elevation. You can see a few little changes in looking at the velocities, but for the most part, it's all handled very well. Looking at the CMS wave domain, we also have a capability to add in a lot of different features here, but we do cover several different processes: showing, refraction, diffraction, reflection, white capping, all these different things. I'll go over a little bit of this and we'll get into more detail probably on Wednesday or Thursday when we start talking about waves. We'll get into this a little bit more. As I mentioned earlier, we do not have telescoping grid availability for the wave models, so we still have to wind up with two different grids if we want to combine these processes together. And it also has some amount of parallel processing within the wave model to handle those calculations as well. Some of the capabilities here and how they're represented, just showing, some of the capabilities with wave generation. So this is all wind generated waves due to a Hurricane Rita. This is Matagorda Bay in Texas, and as the hurricane comes on shore, these directions of the wave energy is changing because the hurricane is moving over, and you're getting those winds cycling around and changing directions. So we're able to handle that inside of the wave model very well, so that we are able to generate the proper waves and how they're acting along a direction that's not specified with spectra. So that's kind of what we're going into. We'll talk about this a little bit more. Some of the other new capabilities with the wave model, we have muddy bottom capabilities where we can add in extra dissipation in some areas that are covered by mud instead of sediment. And so we're just showing a couple of different plots here where we were really over predicting some things before, and then when we changed it to be able to incorporate these muddy areas, then we're getting a much better answer, just some of the validation there. Wave run-up, we're able to calculate the wave run-up using the R2% and have those add extra forcing onto the land cells or the near shore cells to be able to transport some sand in those areas that are wetting and drying and up a slope. Showing a little bit of how the coupling between the flow model and the wave model is done. So as you're setting it up, you actually have a wave model that's run twice. So you have a 0 time and then a time 1. So this could be the very start at 0 hours and then 1 hour. And then the flow model is run between those two times, and the wave forcing changes through time until you get to that ending time. Then it runs the third time period and then does that again. So there's just an idea of how these things are running and what to expect when you're visualizing the runs going. Again, we're showing here a little bit of how the different information is shared between the different models, but we've already covered that. So now talking about sediment transport, there's 3 different choices for the morphology model. For the most part, the default right now is non-equilibrium with total load. The other 2 are only available for explicit solution scheme and are really no longer recommended due to some things that I'll talk about in just a minute for sediment movement. Within these different morphology models, there's different choices for how to move that sediment around. And so we have different capabilities here that have been added over the years: Lund Serp, Van Ryn, Watanabe. Soulsby Van Ryn, and with addition of 13.2, we're now actually able to work with C2 Shore, or Seashore is embedded in the CMS model so that we can get some cross-shore movement that's very close to the shoreline. We also are able to handle hard bottom, which is just a non-erodible layer at a certain level, or it could be jetties or structures, and just making sure that those do not erode. Avalanching due to the slope as the sediment is moving around. You have to always make sure that you're moving that sediment in such a way that it's realistic, so we can't get slopes that are too large, so we have to move that around after the fact. Then the bed slope you can define, and it does have an influence on the bed load. And then run with either a single or multiple sediment grain sizes. There's some documentation here. We have the SERP website, so it's serp.usace.army.mil. There's a lot of different tabs up there. We have publications, and it's got a lot of different things, not only CMS, but everything else for SERP. We don't necessarily have one set aside for just the CMS pages, but you can look through, and they cover technical reports, tech notes, could be journal papers, conference papers, things like that, and all of that's available on our website. We also try to keep up a SERP wiki, which allows us to show different screens and edit it a lot easier than we can in an actual publication, since you can't go back and really update that very easily. So we try to keep this up to date. We are a little bit behind, so we're taking an effort right now and catching up to the latest SMS versions and changing some of these pages. And we've recently released CMS as open source, and so we have a little bit more documentation on that and how to compile and work with CMS on another website here. Just showing real quickly the documentation, the website. Like I said, we have a lot of different products. One of those is CMS, and you can look at any type of that information. A lot of publications, and as I mentioned earlier, we have tech transfer and a lot of different links here that we've grouped in together, and so you can pretty much find anything that you might want. We do record most of our webinars, and some of the workshop material is always put up for users to access later on and go through that material, just like this information we've made available. On the wiki, we have a good documentation here. The left-hand column basically has all the equations and how we use that information. Then there's information in the middle column on how to actually use within SMS different things, how to define the interface. And then on the right-hand side, there's a long list now. This has grown with a lot of different test cases and utilities and other things that you can use as well. So look over these pages and see what information that you might need. We do have some tutorials set up inside of here with links, as well as, like I said, the equations and things like that. All right, and so that's it for this first presentation, just an overview of the SMS and the CMS. This is our team that we work with. So if you have any questions, please contact one of us here. For the most part, the first 5 of us are in and working. Brad is mainly a developer, so he may not have all of the answers you might need unless it relates to sediment transport or the cross-shore capabilities, things like that. But let us know how we can help you, and that's it for this presentation.